Welcome back. Let's continue with our discussion on further logarithm. And now I want us to look at what we call solving logarithmic expressions. Logarithmic expressions. So, when we talk of an expression, bear in mind that an expression is not the same as an equation. We shall be talking about the expression and also the equations, but we need now to simplify expression. Expressions are different from an equation that in an equation we have an equal sign, but with this one it doesn't have that equal sign. So, like for example, let's talk about our example. You are told that evaluate or solve. You are told solve log to base 3 81. Now this is a logarithmic expression because it does not have an equal sign. Now for you to be able to solve this one, you have to write this as an index form, because you cannot solve this using a mathematical table, neither can you use a calculator to solve this. So the first thing you do, you just need to introduce an equal sign. You say this is equal to t. Now you can write this into an index notation. So this will be, the base remains 3, this is t is equal to 81. Now, having written this as an index form, now you are able to solve, because now you are able to break this into base 3. When you break 81 into base 3, it goes, this is 27 by 3, 9 by 3, 3. So it is the same as 3 raised to power 4. So we can say that 3t is equal to 3 raised to power 4. And we say that if the basis of any of two numbers are the same, the powers also must be the same. So our value here of t will be 4. Now, reversing it back to the logarithm, we find that log to base 3, 81 is equal to 3, because now we substitute the t with our value that we have got. This is what we call solving logarithmic expression. Solving logarithmic expression. Let's look at our next example. Let's look at our next example. Our next example. This was example number 4. So and now we talk about example number 5. This is example number 5. Example number 5. You are told solve for y. Solve for y in log to base y 8 is equal to 3. Log to base y 8 is equal to 3. So for us to solve this one, we simply need to write this again into index notation. So it will be y raised to power 3 is equivalent to 8. Now, for us to get the value of y, we can simply get the cube root. We get the cube root on each side. This is the same as saying y is equal to 2. Alternatively, you could have also said these are alternative. So you can say that y raised to power 3 is equal to 8. Suppose we break this into the simplest base. So if we break it into the simplest base, it becomes this is 4 and this is 2. So it becomes 2 raised to power 3. So you can say that y raised to power 3 is equal to 2 raised to power 3. But we say what? If they must be the same, Then if the powers are the same, then the base are the same. So we say that the value of y will be equivalent to 2, because now you cancel out the powers. So you are left with y is equal to 2. And that is the solution. That is the solution. Now, let's look at now what we call algebraic, not algebraic, the logarithmic equations. Logarithmic equations is our next subtopic. So we talk about logarithmic equation. Logarithmic equations. Logarithmic equations. We have said that the logarithmic equations differ from expression because that they have two sides. They have the left hand side and the right hand side being separated by an equal sign. So that is the difference between an equation and an expression. So let's consider this example. We are told that solve for x. So this is our example. Example 6, we are told that solve for x in the following. So we have part A is 2 log 2 to base 2. So this is 2 plus log 2 3 plus log 2x plus log 2 base 2 x is equal to log 2 5 log 2 base 2 5 plus 1. And then part B we have log x plus log 5 is equal to log 30. Then we look at the solutions. Then we start with A. Now, for us to solve any logarithmic equation, you should have this in mind. All the values on the left hand side and the right hand side must have the common base, This is very important, the learner, that you should understand. Whenever you want to solve an logarithmic equation, the left hand side values must have the common base as the right hand side. So our first thing in our Roman 1 or our part A, we have to write this into base 2. So we can say that we know that 2 is given by log 2 base 2, 2 raised to power 2, which is the same as log 2 base 2, 4. So instead of writing the 2 on this side, we now substitute it with log 2 base 2, 4. So it will be log 2 base 2, 4 plus log 2 base 2, 3 plus log, this is log 2 base 2 x is equal to log 2 base 2, 5 plus, again on the right hand side, see this is 1. We have to write it under a base 2, log 2 base 2. So this will be log 2 base 2, 2. Log 2 base 2, 2. Now, from here we can just use our laws of indices, laws of logarithm. So we can say log 2 base 2, we factor out whatever is in left hand side, and the common factor there is log 2. So we have 4. Because here we have an addition, we substitute it with multiplication. Then again we have an addition. So this will be multiplied by x. This will be equivalent to log 2 base 2. We factor out on the right hand side. So this will become 5 multiplied by 2. Then from there, this is the same as saying log to base 2, 12x is equal to log to base 2, 10. Now, when it comes to this point, you just need to drop the logs. Log to base 2 is common, so you drop it. So it will be 12x is equal to 10. Under this, you drop the logs, and log to base 2. Drop log to base 2. So we can have our value of x to be, you divide by 12. So the value of x here will be 5 over 6. 5 over 6. And that becomes the solution to our first question. Now let's do the second part. The second part of that. So we are given a log x plus log 5 is equal to log 30. Now, remember we said that any log which is not given a base, we take it to be under base 10 because we call it a natural logarithm. So, this all these logs have a specific base, and that is base 10. So, if they are under base 10, then we just need to factor out the log, because the log is what is common. This will be x multiplied by 5 is equal to log 30. But now you see, now we have log and log. We can drop them. So we have 5x is equal to 30 divided by 5 divided by 5. So the value of x will be 6. The value of x there becomes 6. So it's important that you understand, whenever you are given a logarithmic equation, the basis must be the same on either sides, and then from there you apply the laws of logarithms that we have covered sometimes back. So this what you are expected to do. You just consider everything, and remember, this must be done when all the bases are the same. If they are different, then you are not going to do it the correct way, because you must write everything under a common base, under a common logarithmic base. That's why we converted the one into to log 2 raised to power 2, or log to base 2, 2. The other one became log to base 2, 4. So after that, that's when we were able to evaluate that.